Hello, everyone. My name is Karl Zygmunt, and together with Miha, we will be presenting today about YARP and custom reverse proxies for .NET containers, how you can do them with that. So let's get started. So what's YARP? It's an acronym. There's two actual explanations. We like the yet another reverse proxy. You can as well call it YARP is a reverse proxy, the typical one. We're on GitHub.io where you can check us out. And I'm gonna as well very shortly answer the question like, why would we build yet another one? Like, even especially in the name. Actually, the key reason is that we wanted to deliver, we saw the need from customers to actually have something highly extensible in a reasonable way, code first, via code, very customizable, and we don't see any reasonable offering out there. So that's where we try to fill in the place, and using .NET and C# for that. We're open source, so you can find us on Microsoft/reverse proxy. And overall, our reverse proxy is a layer 7 proxy, which means that we terminate the requests that come to us. For example, if it's HTTPS, we're going to end it, and we're going to reissue new requests. So the same, private keys and stuff will not flow past the reverse proxy. You might have heard about other popular reverse proxy in the industry, Nginx, HA proxy, Envoy, Ocelot. Again, what distinguishes us from those is like in those, when you do customization, it's usually like config first, and like when you do customization, it's usually like either C++, Lua, or kind of some type of scripting. Our yet another reverse proxy, our YARP proxy, was actually designed with extensibility and customizability in mind, and C#.NET is the language that we used. So let's look actually a little bit what is a reverse proxy in case you're not quite familiar with that. So imagine that you have this public internet that's hitting your endpoints, and the reverse proxy is basically a choke point or a public endpoint that you're gonna expose, and you're gonna hide all your servers behind it. So that's what we have on this picture, right? Reverse proxy is there, and you have like multiple services that you're going to expose through kind of different APIs via the reverse proxy. We have the woodgrovebank.com. Hopefully, it's a fake name like Contoso and nothing existing. But you can imagine that you have like different names, different services from different teams, something large scale. Reverse proxy is something that kind of puts it out. Obviously, it doesn't hide only that. It can do things like load balancing. It can offload stuff from your servers like authentication, encryption, compression, caching, anything you want. So that's it. And we can actually look at a little bit more. What else can reverse proxy do to you? For you. So here's actually a list of the classic things that you can see from reverse proxies, that you can use them. Like either it's load balancing. So imagine that you have multiple services or multiple servers that can scale out, and you want to kind of make sure that they get equal share of stuff. Like pretty simple. All reverse proxies do that. A/B testing is another popular request. When you imagine that you have a new version that you would like to test out, but you're not quite sure, maybe you're kind of testing if users like this web UI or that web UI or menu or how something works, or you want to do version rollout, right? You have a new version and you slowly want to kind of take it out, because if you put it out there and you made a mistake, it would blast all your users, maybe render your service not working. That's not good. So for that, reverse proxies are useful. Other benefits, health checks, either active or passive. Active, that like reverse proxy pings the backend server, or passive, that it monitors like which request kind of succeeded or failed and whatnot, and kind of keeps track of that. And if the backend or specific machine seems to be a little bit too unhealthy or not responding, maybe timing out, then you're gonna send less traffic or eventually kick it out entirely. So again, all the goodness that you get from reverse proxies. The other thing actually I alluded to in previous slide is kind of API management. But basically, you have the choke point, the public endpoint of the API. And over there, you basically can have consistent API, and whatever you do on the backends, if you split services into two or in microservices, or if you create some kind of deep nesting over there, it doesn't matter, because everything is hidden behind the reverse proxy. So it kind of creates this indirection between the URL space or the public API and whatever is on the backend. And as I mentioned, offloading to the from the backends, that's another useful thing. So let's look actually at some advanced scenarios, and we believe that some of these, not all of them, are unique actually as well to YARP. So one interesting thing that we saw is, for example, authentication migration. We saw customers having multiple services. Maybe they bought a company, a bunch of services came, or over time there was like separate services. They decided to kind of have unified endpoint for their like APIs or for the company, and suddenly they're facing like, oh, they have different authentication and it's hard to migrate the services. So they basically put new authentication on the reverse proxy, which handles the authentication and then just talks with the old authentications to the services, and they have more time to upgrade. Another interesting one is the cloud to on-prem communication. So normally on-prem in enterprise scenario, if you're on premises, you can go to the cloud. That's easy, right? But the cloud cannot come to you because you're hidden behind the firewall. So sometimes you want to punch a hole and basically say like, hey, for this specific machine or maybe set of machines, I want them to actually be able to reach out back. Something like VPN, but you don't want to set up VPN for whatever reason. So that's actually doable today with, for example, with YARP. It's 100 lines of code. You want to make it more streamlined in future. Other things which are, again, more traditional things are Kubernetes or Service Fabric ingress controls. For both, we have plugins. Kubernetes is still in beta. Service Fabric is actually used by a couple of customers already. And we're going to show later on, in the second demo, actually .NET Framework migration to .NET Core, which is a little bit unique to .NET. And that's actually where YARP, even though it was not designed for that, actually shines quite well and allows you to slowly migrate, components from one framework to the other. And with that, actually, I'm going to pass the word to Miha, because he's going to show the first demo, which is going to be about app services and how you can do discovering of new services. So, Miha.
Hey everyone. So for this demo, I have two services running in Azure App Service, and I want to expose them in a unified way. For example, I want one endpoint that users will connect to, and then if they, for example, put /todo in the path, I want that request to be handled by my to-do service. And if they go to /weather, I want that to be handled by my weather service. So let's take a look at how that actually works with YARP. In here, I have a few projects. This is the to-do service. It's a very basic ASP.NET Core project using minimal APIs. You can get the list of all the to-do entries, or you can post an update to them. Normally, you would use a database here, but for the purpose of sort of the demo, I'm just using a dictionary. It's all in memory. And then the other service, I have a weather app. This is something that most of you are probably familiar with. It's just the default template whenever you create a new ASP.NET project. Now, how do I get that to work together with YARP? So I've created a new ASP.NET Core project, and I've added the YARP reverse proxy NuGet package to the package references. Now, as with many other packages, how to actually include them in your project, you would add something to your services. In this case, we call add reverse proxy to register everything in DI. And then we call map reverse proxy to register all the middleware. Now, YARP configuration can come from anywhere, be it config, for example, config files. But for this demo, I want to show how you can actually generate the configuration dynamically at runtime via just code. So I have only 2 services right now. I could hard code them, but I might have 10 services later on. So I would like that discovery of those services and the configuration to happen automatically, and I just have to write the code once. So to do that, I'll use one of the extension points that YARP offers me, which is the iProxy config provider interface. And that gives me full control over creating the configuration as I want. If we look at the implementation, I just have a timer, and every 30 seconds, I'll reach out to the Azure Resource Manager API to get the list of all the web apps running in my resource group in Azure. And I'll take those names and hosts, and I'll generate the YARP configuration that corresponds to them. And once I have that list of routes and clusters, I'll call an update method on my configuration to take all those objects and recreate the configuration, reload the routes, and YARP takes care of all of that. Now, all the details about what you can configure in code in configuration is explained in a lot more detail in our documentation, and we also have a few more samples available on our GitHub. But for this demo, all I'm doing is I want my service, for example, to be reachable at /todo. So I'm specifying that the route begins with a / the name of the service URL. And then as the cluster, I'm defining the set of destinations that I want the YARP to proxy to. In this case, I just have one destination. So I'm creating a dictionary with just a single entry, which is the host of that service. So I can now show. This is the YARP application that I've just shown, deployed in Azure Web Apps. If I now query the /todo endpoint, I will get a response back from my to-do service. And if I query the weather endpoint, I will get back a response from the weather service. And if I added a new service now, it would automatically get picked up by this configuration and get automatically loaded. Now, it might seem silly to write this code for just 2 destinations, but you can imagine that you can pull this information from anywhere you could imagine, and you have full control via code. And something that Carl mentioned is that you can also use YARP as a Kubernetes ingress controller. Now, how that is implemented is actually pretty similar. It's also implementing the iProxy config provider interface, but instead of fetching information from Azure Resource Manager, it's talking to the Kubernetes API to get the list of ingress resources that way. And with that, I'll hand it back to Carl.
All right. So speaking back about YARP, so what you saw from Miha, we as YARP are a library. We are not an executable. It is something that we wouldn't do eventually, but it's actually not our primary goal. So it's a library that you can kind of create in your ASP.NET application, and you can customize it. You have seen actually customization even of the configuration and whatnot. We have many and as you heard, actually, even the Kubernetes is using the default customization and extensibility points. So it's not something special that we would do for Kubernetes. We just have to go and implement certain interfaces and grab the information from somewhere. Right now, at free releases, 1.0 to 2.0, and as I mentioned, extensibility in C#. We have seen that. We are designed layered, so there's a bunch of layers. You can actually use 2 types. Either you have the default route, when you have health checks, you have the routing, obviously routing, health checks. Then you have things like transforms and whatnot, and then you eventually issue the request somewhere else. So there's basically a huge, not huge, but a pipeline that you can follow. There's as well advanced mode, which actually a couple of largest services we're going to talk about later use, when you can basically say what, I don't like this kind of pipeline because I have even more demands, I want even more extensibility. I'm just going to use parts of that and reuse parts, so they can actually build their own pipeline and just use hey, I'm going to send the request over here. And in their own pipeline, they can leverage bits and pieces, for example, health checks, and they can replace all the rest, or they can only use routing and stuff and do their own pipeline. So highly customizable, layered for general reuse. We are cross-platform because it's .NET, Windows, Linux, all free platform, all free architectures. It makes sense. Again, Mac is not here because I think it actually might work on Mac, but the primary is server-side. Mac is more for development, right? We have a great perf, so you're gonna see this as well testimonies from our top customers. But we're highly comparable actually with other reverse proxies. We have perflab where we measure things to make sure that we don't neglect some things and some stuff. And you have as well availability of the latest protocol. So gRPC, HTTP3, or HTTP2 WebSockets with the 2.0 YARP. Most actually of these protocols, as soon as they light up in .NET, they will automatically light up as well in YARP. HTTP2 WebSockets was a small exception that it needed few lines of code changes in YARP, but it was not that we would have to rewrite YARP or do something really magical. It was really kind of small touches. So whatever new protocols and stuff .NET is going to bring, they're going to show up automatically in YARP. The interesting thing that how we're using internal YARP is as well not only to kind of deliver to our customers, either internal customers or external customers, but we as well use learnings from it to kind of improve performance of the .NET itself. Because it's a kind of high performance scenario, and we have actually now a comparison with other reverse proxies. We can see actually where things are kind of not so great, and where we can even get improvements. So, over the last actually 2-3 releases, you have seen a bunch of things coming to .NET itself, making improvements not only to YARP scenarios, but in general to networking and in general to .NET developers. Well, let's move on to next slide. All right, and that's that's actually YARP in production. So we listed like 2 internal partners or customers that we have data from, most interesting. So Upservice is one of them. So that's actually what Miha just showed. He used Upservice. Whenever you use Upservice, not only Miha, under the hood you're actually using YARP. They blogged about that on .NET blog. So there's a .NET blog post from August 2022. So just like recently, half a year, let's say. And they have lots of statistics and things that you can go through in details, but highlights is that they have actually pretty impressive RPS. It's like, in average, if you don't count spikes and anything, it's almost 2 million RPS. That's actually a lot. 14 million host names. They're running on .NET 6 plus YARP. I believe they have plans actually to upgrade to .NET 7 and obviously later to .NET 8. Now, why would some large service like Upservice move to YARP? So here's actually the benefits they got, and they, obviously they kind of looked at it upfront, and so are we going to get benefit or not? But first thing that actually they used to have IIS plus ARR, and on Windows and on Linux they use Nginx. So they had this kind of dual thing, dual configuration, different way. Keeping it the same was kind of a little bit not so nice. And YARP was something that actually worked the same way on both things. So that was actually one of the benefits, including the fact that like some of the new protocols were tied to the IIS, the support, and that is actually tied to the operating system. So it took a little bit longer sometimes to get for example, gRPC or HTTP free. Given that .NET is user mode, like you get those things very quickly as soon as .NET supports them. Obviously, they got actually good perf improvements, 80% throughput on perf tests. So again, it's just perf tests, but those were targeted perf tests for Upservice. They didn't get that huge improvement in the kind of real life traffic, but it was significant enough to actually deliver some lower CPU usage. And lower CPU usage means that obviously you're paying less money for running your service, which means you can earn more money. That's useful for any service out there. They got more extensibility, as I mentioned, and the new customer scenarios. So the protocols that I mentioned, gRPC, HTTP free, something that they didn't get before, suddenly with YARP lit up immediately. They got actually some new features from us as well, or not only from us, but by migrating to YARP, per host cipher suit configuration or customer pages and those things. So that's actually all beautiful. Again, check out the blog post to kind of learn more about that. The other team and larger service that kind of is using YARP these days is Dynamics 365. They actually announced their support in .NET Conf last year, or not last year, but year ago, year and a little bit more, so 2021 November. And as of today, actually, I updated today. I got permission to share updated numbers. If you remember what was there, probably not, but if you look at that, these numbers are actually 2 times or 3 times larger than was a year ago, which is actually pretty impressive for that service to grow. So right now they're actually at roughly, if you don't count spikes again, 112K RPS, 1000 RPS, which is pretty impressive as well. Obviously, if you compare it to the 2 millions, it's 20 times smaller, but hey, not everything is Upservice. Even the 1,000 RPS is pretty big service. They have 13 petabytes of data transferred per month, and actually they run kind of amazing 1,500 instances of YARP. It's kind of a couple of layers and whatnot, and they're getting kind of a really good success rate on 7 nines, which is again impressive availability. All that with high scale, high performance cloud data infrastructure. So looking at that, they're actually the original authors. They are running on .NET 6. So we kind of took the code from them. We generalized it more. It was at the time when we were kind of looking to kind of leverage something or write something from scratch. So we kind of learned from their designs what they need, and then generalize it for more customers. We have actually more partners and even external customers using YARP, Bing, and other services. We don't have data from them yet to share, but something that might come in future. So let's move on to the next thing. So if you want to get started with YARP, where do you get started? As I mentioned, it's the GitHub.io/reverse proxy or Microsoft/GitHub.io. You're gonna hit this page where you can see there's actually the code that you can start with, the middleware. You can see it on the left side and as well on the bottom right bottom side of the screenshot from the page from the articles. It's actually very similar, or it's almost identical with what you've seen Miha showing and demonstrating, except that this one loads configuration from config file instead of having it dynamic, like he already showed you kind of some of the extensibility. Most customers actually use, well, most, depends. Many customers use the config and then kind of customize other things like, for example, transforms of headers and these type of things, or authentication and other stuff with code. You can see there's lots of topics that are like, specialized into what people might want. So health checks, tracing, code balancing, session affinity. So go and read it up. And with that, actually, we're gonna head to second demo, which is about migrating applications from .NET Framework to .NET Core. It's part of larger migration of ASP.NET migration. You can see the link below. And Miha is gonna walk you through demo. So if we can switch to Miha's desktop, screen, he will talk about the rest.
Hey again. Yeah, so it's a very common problem that our customers face is that they have services, large services, running on .NET Framework using ASP.NET that they're trying to migrate to ASP.NET Core. But migrating a huge service all at once is sometimes next to impossible, just because of the sheer amount of logic that the service is using. So we have some tooling that will help you do that migration incrementally. So for this demo, I have here a .NET Framework app using two controllers. Now, in the previous demo, I had a similar to-do and weather service running as two separate services. In this case, I have those as just two separate controllers in the same project. So we see the same sort of to-do application running in memory and a weather controller. And then the tooling also comes with a Visual Studio extension. And I've used that extension to automatically generate my ASP.NET Core project that I'll be migrating all of my logic into. And I have that over here. I've taken the time also to migrate one of these endpoints. So I've moved the to-do controller, used all the nice features of ASP.NET Core and newer C# versions. And what I would now like to happen is that if I direct all of my traffic to the new ASP.NET Core application, I would like requests to the controller, which I've already migrated, to end up in my new application. But for example, if a request comes in for the /weather API, which I haven't migrated yet, I would like that to be handled by the old application. But I would want all of that to happen transparently to the user that actually calls its APIs. And how this migration scenario achieves that is by using YARP to proxy those requests back to the old application. So if I show here, I have the ASP.NET Core application running. And if I issue a request to the to-do endpoint, I can see that the response headers indicate that the server that handled this request is Castrol, since Castrol is the default web server whenever you create a modern ASP.NET application now. And if I query the weather endpoint instead, I see two things. One is that now the server that responded with the request is Microsoft IIS, because the request was handled by the old framework application. And also in my console logs for the new ASP.NET Core application, I can see a few entries here telling me that the request was proxied back to the old framework application. Now, how does this configuration actually look like for YARP? The tooling generated this program file for us. And similar to the previous demo, to make use of YARP, we're calling add HTTP forwarder to register all the necessary services in DI. And then we're mapping the routes. In this case, all we care about is just the catch-all route. So anything that is not implemented yet in our new application, we want to proxy those requests back to the old application. So we register a catch-all route, but set the priority to lowest, the lowest possible thing. Now, the tooling doesn't stop here. It can help you as well with, for example, sharing session state between your new ASP.NET Core and the old ASP.NET application. It can help you with authentication and so on. But this demo is just here to highlight the YARP portion of this scenario. And as you can see, we've made one call to register the services and then used 2 lines to configure YARP. And we're already getting a lot of functionality out of that. And also another thing worth highlighting here is that YARP is a library. You can add it to any ASP.NET project. So in this case, we don't have to deploy a separate service. We don't have a separate process to manage this migration. It's all happening just as yet another middleware, yet another service inside of your existing project. And once you're done with migration, you move everything over. You can just remove this little bit of configuration, and you're all set to go with the new, with your migrated app running on ASP.NET Core. And if you want to learn about more information about what this tooling can do for you, you should visit aka.ms/ASP.NET Core migration. And that should be it for our demo. And I think we should have some time to take a few questions.
Awesome. Thank you so much, Miha and Karel, as well. So we do have some questions. I know that the one and only David Fowler hopped into the chat, but it's always good to reiterate as well. So good question here. Does YARP support request response body streaming for use cases when API consumes/produces a large file?
It sure does. Yeah, you can stream large content through it. Or for example, if you have a long-lived WebSocket session, all of that will just happen transparently with default configuration.
Or gRPC requests are another long-running sessions as an example. Yeah.
Perfect. And a follow-up they had to that was also if it does chunked responses as well.
Yeah, so all the protocol details, such as whether the response was chunked, it had a content length header, and so on, that's all handled for you. Of course, you have extensibility points, right? You can write code at any point in this request to modify things if you wish. But by default, if you have a compliant browser, for example, that's reaching your service, all of these scenarios will just work.
One way how to look at it, if .NET supports it, and it does and tries to support every part of the protocols, right, then YARP supports it. Like that's the beauty actually of YARP being on top of .NET, that you don't have to do your own protocol parsing and that stuff. You just rely on the networking over there.
Gotcha. So kind of the follow-up question of sticky sessions, I guess kind of to your point there, if it supports it, and how does YARP work with that specifically?
Well, by sticky session, I think that person meant probably session affinity. For that, I actually, on the page that I showed, I actually called it out. That's one of the topics we have. Like, yes, we do support that. That's actually not part of the protocol, HTTP protocol itself. It's built on top of that. And yes, we do support that, and you can even probably customize it. Miha, do you have something to add on that?
Yeah, it's built in. It's enabled by default. And of course, as Karel mentioned, you can customize it. So you want it in a cookie, you want it in a different header, so on. You can configure anything.
Perfect. I guess also to that point, I guess if it works with .NET, it should work. So Angelo is asking here, does YARP support SignalR?
It does, yes. SignalR, if you're using WebSockets, or now even HTTP2 WebSockets, all of that will just work through YARP.
Very cool. And this is kind of a bigger probably topic and discussion point, but SNDA was asking, if you're using IIS, does YARP eliminate the need for IIS in certain scenarios?
Yes, it does, right? Because that's the benefit of the ASP.NET Core. ASP.NET Core eliminates the reason to do IIS, and YARP is on .NET Core or ASP.NET Core. So with that, unless you want to, you don't have to use IIS. Kestrel is, for the cool kids, I guess.
Cool. All right. Well, I think that we have all the questions answered, a lot of the good stuff in there, and I appreciate David Fowler, the one and only, popping in to answer questions as well. So Carl and Miha, thank you so much for the awesome session on YARP. I appreciate it.
All right. Thank you.
Cheers.
See you, folks.
Have a great one.